lines and what you want to know about the slopes of both of these types of lines. Number one, for parallel lines, they will always have the same slope. So if you were to take your graphing calculators and just put in a whole lot of different equations that have the same slope, you'll see that the lines will remain parallel to each other. Okay, for perpendicular lines, this part right here is very important. You're going to be taking the opposite reciprocals. That means you take the opposite sign and then you reverse the numerator and denominator. Okay, opposite, reciprocal. My fault. Thank you. All right, so you got parallel lines have the same slopes. And guys, this is the symbol for parallel right here. Okay, it looks like two lines. So you'll use that symbol when you get to geometry. And this is the symbol for perpendicular. Okay, it looks like an upside down T. Okay, that's the symbol for perpendicular. So this is saying y equals 3x plus 4 is parallel to y equals 3x minus 5. How do we know they're parallel? Because they have the same slope. And the slope is what? 3. Very good. Perpendicular lines have opposite sign and reciprocal slopes, which means, like, see how this slope is 2/3 and this one is -3/2. That means you take the opposite sign and then you reverse the numerator and denominator. So these two lines would be considered perpendicular. Okay. Now we're going to follow the same steps for both types of lines. We're going to make sure we are using the right slope. We're going to then put the equation in point slope form, and then we'll solve it for y to put it into slope intercept form. So we're going to be doing the same process for both types of lines. So let's start with this one. Okay, so let's open that up, and we're going to start with question number 1. So what I have you first to do is just identify the point that we're using. So that's easy. It's right here, -2, 8. And identify the correct slope. Since the question says, I want a line that is parallel to this equation and it passes through this point. Keyword right here, because this tells me what slope I'm using. So remember we just said if it's parallel, we're using the same slope. So what slope am I going to use? 2. Very good. So after that, we're going to now write it in point slope form. So remember point slope form. So we're going to say y minus the y coordinate, which is 8, equals 2 times, parentheses, x plus 2. Is that right? So now we have it in point slope form. So what was the next step after we put it in point slope form? We're going to solve for y to get it into slope intercept form. So let's go ahead and solve this for y. So we'll distribute this 2. Okay, add the 8 to the other side. And now I have y equals 2x plus 12. So now I have written this into slope intercept form. So if I were to put this on my calculator and I put in the original problem right here and I put in this equation, I would know that they're parallel. You can see because they obviously have the same slope. But not only that, if I just put this one into my y sub 1, okay, everybody hit your y sub 1 on your calculator, and I want you to type in our answer, which is 2x plus 12. All right, so once you put in 2x plus 12, remember the whole problem was we want to write an equation that's parallel to this, and it has to go through this point. So like if you were taking your test and you want to know, oh, I want to see if this answer is right, you would type it in, then go to the table. Everybody go to the table. And in the table, you would look for this point. And that point should be in the table. How many people see that point in the table? All right, so now you know you have written an equation that's parallel to this given problem here, and it passes through this point. because we can come up with a whole lot of equations that's parallel to 2x plus 5 as long as we're using 2x every time, but specifically it has to pass through this particular point. Okay. All right, so now what I want you to do is to graph it. Graph the new line. The original line is already there, so you should already have the black line drawn for you. Now you're going to make, the parallel lines. So start at +5 and so forth, do your slope. And there's that point that we're looking for, -2.8 is going to be right there. Okay, so I'll give you a minute to do that. And are there any questions for the first example? It's pretty easy because once you guys already know how to put things in point slope form and solving for y, so we just have to make sure we're using the correct slope. Okay. All right, so we're going to move on to number 2. Now, number 2, we're switching gears here, guys. Notice that this says perpendicular. Okay, you might want to underline that, circle it, whatever, so you'll know we're not doing parallel this time, we're doing perpendicular. And what does that mean? That we can't use the same slope, we have to do opposite sign and reciprocal slope. Okay, same point, -2.8. So what will be the opposite sign and reciprocal of 2? Everybody. -1/2. Remember, we got to take the opposite sign and reverse the 2/1 to 1/2, right? So once we have that, we're ready to put it into point slope form. Okay, once we have the right slope identified, so that's y - 8 equals to -1/2 times x plus 2. So all we did was have to make sure that we have the right slope. So that'll give us y - 8 equals -1/2 x. And this is going to be what? -1. Very good. Then we're going to add 8 to both sides. So in slope-intercept form, y equals -1/2 x plus 7. All right, so you want to graph that starting at your +7 on the y. And then if you go up, then you want to go left 2, or you can go down and right. Okay, just make sure that you're graphing it correctly. And your graph should look like this. Okay. And a good thing about graphing, you can always, since it's already in slope-intercept form, you can put these 2 lines on your graphing calculator and make sure it looks like the one you have on your paper. Okay, that's what I would do if I'm taking like an assessment or you're taking your SOL test. You want to make sure that, you have the graph correct. All right, so I have modeled 1 and 2. Now you're going to do 3 and 4. Okay, and then we will check the answers together at the end. So I'll give you time to work on that now.